Right, this is a Noco G15000. The device has no power, so we plug it to the power. Yeah, nothing. I took the device apart, and in this device we have, this is like a power supply, switch-in power supply. We have two diodes here, one MOSFET or transistor, and we have another MOSFET transistor here. There is optocoupler and transformer. There is another transformer here. There is a small AC right there. That's a fuse. And this is a rectifier bridge. So yeah, we have no power, so the first thing I'm gonna check this fuse and this NTC chip. So we have the fuse right here. The fuse is open. Yeah, the rectifier bridge is used as a two diodes. So there is one diode here and then another diode right here. So here, so we have show right here. The NTC is good. This one from the plug-in wire, it's go right here all to here, I think, or from here. Okay, and from here let's go somewhere. To the capacitor. Then yeah, the input should go to the transformer, to be here. So let's check this one. Yeah, it's shorted. All the pins are shorted. Yeah, that's the source. The negative side of the capacitor, it go to the source in the MOSFET, and that's the drain is go to the transformer, and should be, this is the gate. Let's go right here. Let's go right here. And let's go to this IC. That's the switching IC for this MOSFET. So I need to check this MOSFET and see if there is still a short there. Okay, so do we have a short right here? Yep, completely shorted. So we need this. So that's the first thing we need, plus the fuse. Okay, let's see if we still have a short. And we need to check these diodes, because that's where the gate, and as you see, the gate is shorted to the source and to the drain. So for sure the high voltage is go through this one. We need to check these diodes. We can't check them in the board because it's connected parallel to this resistor. Well, that one is good, but this one, Yeah, this diode is connected parallel to this resistor, but this one is not. So we need to remove this diode and test it. And we need to check the IC to see if we have the oscilloscope wave in this pin, the switching wave. Alright, let's see this MOSFET right here. No short. No short in these diodes. So I need to remove that this fuse as well. Yeah, the fuse is a 10 amp. This is 10 amp fuse and this MOSFET. So I'm gonna look for the replacement. Then we see how it's gonna go. And I jumped the fuse, just I put a tiny wire over there to check if the device has the power first. This is just like a power supply. This is a standby and low voltage transformer for like this chip and to power on the controller. This one here. And this is the high voltages and for boosting and charging the battery. And there is a power manager IC is right over there. That's one is a switching IC and MOSFET built in. So I'm gonna power it on, then we see if the device is gonna turn on, like any life on it. So I plug it to the power, nothing. So we have a diodes here. Yeah, no power. The device is completely dead. So let's see. Do we have 160 volt in this capacitor, 160, this capacitor 160, and both capacitors should be 3 something, almost 320, because these two capacitors connected on series. So for the IC to work, we need the VCC and the voltage start. And we have two resistors here. They are on series. That's pull down the voltage. And that is a 620 kilo ohm each. So the output of this resistor, we have 76 volt. So the resistor, before the resistor 160, 76. This resistor is 0 volt. Coming to the resistor 76 volt, the output of the resistor 0 volt. So that's the voltage start. It's gonna come to this one. Yeah, we don't have the voltage start here. I did follow the traces for the IC, and this is what I find. We have these two pins right here is connected to the ground. These two pins right here is connected to the gate and connected to the transformer, the small transformer. And this pin here, it's connected to the optocoupler, so that's a feedback. And we have these two pins, both of them they have 100, or they are connected to to the voltage start. So must be one of them is a voltage start, one of them is a VCC. And we have this pen is connected to the ground with the 2 ohm. Anyway, so we need to check in these 2 pins for the VCC. Let me discharge the capacitors. Capacitor discharged. So let's check the resistance. So 440 kilo ohm. 440 kilo ohm. So this multimeter is not like, but look like that resistor is not open. So the resistance on it is reading fine. But once this side of it is show 0 volt. This side it show like 70 something volt. Alright, let's check if the VCC this side is shorted. No. No, but still, I'm gonna take this IC, then I'm gonna measure the voltage right here to see if we have the voltage. Because could be the IC is bad. So I remove the IC and let's see. We have a couple of diodes over there. So I have 1, 2, and 3 diodes. Need to check them. So there is a diode right here. So that diode is good. Can have reading, no reading. So reading, no reading, and 1 diode here. No reading. So it's good. I have another device similar to this one. Is an old model. This one here, and we can take some parts, put it here. Yep, that's the IC, and is this one OB2334 EB. Yeah, I did check online for this IC, and I can't find anything from DGK or here in US, but can be ordered from China. But before we do that, let's check the voltage of the VCC if it's there. Alright, plug it to the power. So that's the ground. And let's see. Okay, we have the voltage out of that resistor. But because we have no load, that's why we have 75 volt. 75, and it's go to here. 75, next one, 75. That's not the VCC voltage, but it just because the IC is not installed and there is no load in the resistor, that's why it showed that voltage. Okay, let me discharge the capacitors. Okay, 1 volt. If this IC works, we may see the device has some power. Let's power it on. I did see. Yep, we have light over there. Okay, the VCC voltage should be right here. .21 volt, that's the VCC voltage. So 2 volt right there, 10 volt. A diode and resistor, we have another diode and resistor, we have 0 ohm resistor before the IC, and you can see it's go to here, that's the gauge, and to this pan here. So that's the dry pan and the switching IC. Okay, let's check this diode. Usually this diode is connected parallel to the resistor, so sometimes need to take the diode to check them. So this one is a 0.7 and no reading, so that one look like good. Okay, let me see. 4 kilo ohm, this resistor. Yep, that resistor is still good. This diode here. Okay, yeah, this diode is connected parallel to this one, and we are measuring the resistance of that resistor is a 5 ohm. Yeah, that resistor over there is a 5 ohm. I need to remove that diode. Okay, you can measure it now. Oh, the diode is open. See, no reading in that diode. The resistor shall be good because it's, yeah, 5 ohm resistor. Alright, let me check the diode. So here is another one. You can see the reading. No reading. Yeah, we are going to turn it on and see if we have the wave in this IC. Alright, so let's go check the wave. I plug it, turns on, no wave. Yeah, no wave in the oscilloscope. It's just a line there, just a line. Or could be the IC is bad. And I'm not gonna risk put the MOSFET because it may blow. And I have just one MOSFET here. Discharge. I'm gonna remove the IC and we'll install another one from the other device. Because this diode is gets bad, there is a good chance the IC is bad as well. Yeah, too many components burned in this device. Now let's plug it. I don't see no wave. So could be this IC is not enabled till something connected to the device, like having some voltage from the output to detect, like detecting some battery connected for it to start switching and charging the battery. But that's more safe than using the old IC with the new MOSFET. It may burn it and we lost the MOSFET. So let's power it on. The device power on. I'm going to use a lithium battery, this one here, to check it, check if it's going to start charging. So how much voltage we have in the battery right now? We have 9.8 volt. And they connect the elevator wires. And let's see, this one is go to the ground, to the negative of the battery, and this one go to the positive of the battery. Okay, it's detecting it. You can see the blue. You hear the fan is kicked on because it's detecting something. And let's see what the voltage we have. It was 9.8 before, right? So now look, it's go up to the 10. And this one is going to be over 10 volt. That's the charging voltage, the 10 volt. So it's like a pause. It's give the voltage, then wait for the cells to take that voltage, balance it, then send another one. You can see now it's over 10 volt and it's still going. So the device is fixed. You can see that light is. So this is all for this video. Thank you for watching and see you again.